Hi everyone. Yesterday we have learned the dipole moment and the electric field produced by a dipole at two different points. The one is the point on the axis of the dipole, and today we are going to describe the electric field produced by a dipole on its equatorial line. First, let us take two charges M minus Q and plus Q at the point A and at the point B. And the midpoint of the dipole lies on the point O. And consider a point P which is perpendicularly above the midpoint O. That is, this is the point P we have considered, and join this point P and B. And the distance, the P is located perpendicularly above the point O at a distance R. And now, the negative charge Q will produce an electric field. At the same time, the positive charge Q also will produce an electric field. Let us find out the magnitude of the electric field produced by these positive and negative charges. And here, first, the magnitude of the electric field produced by, or the magnitude of the electric field E minus Q produced by negative charge at the point P. At the point P can, as per the Coulomb law, okay, that is, it gives the Coulomb's law 1 by 4 pi epsilon 0 into Q divided by, and what is the distance between them? The distance between these two from negative charge to the point P, that is AP. So AP square, that is equal to 1 by 4 pi epsilon 0 into Q divided by the AP square. AP square can be written as, so as we know that these two charges, they are separated by a distance A. So since the point P lies on the midpoint of these two charges A, or between the point A and B, the distance between them, this distance is now A. So AP can be written as R plus A square. Now let us find out the electric field produced by the positive charge. Magnitude of the electric field produced by the positive charge Q, that is equal to, as per the Coulomb law, 1 by 4 pi epsilon 0 into Q divided by, what is the distance between them? The distance between this positive charge and the point P, that is BP square. Now we can write 1 by 4 pi epsilon 0 into Q divided by the BP square. What is the distance between them? From A, R plus A square is R plus A square. So these are the magnitude of the two electric charges, minus Q and positive Q. The net electric field produced by these two charges, that is E is equal to, that is the net electric charge field produced by these two charges, that is E minus Q plus E plus Q. That is the vector sum of these electric field, magnitude of the electric field produced by these two charges will be the net electric field produced by these two charges. Now, in order to find out the net electric field produced by these two charges, so we need to consider x and y components. So this is the electric field produced by the negative charge, okay, and this is the electric field produced by the positive charge. Now, if we take the components of x components of x and y components of these two charges, angle theta between these two electric fields, okay, both have equal magnitude but they are mutually opposite in direction. From this figure we can understand that, so since these two components have equal magnitude but they are mutually opposite in direction, so they just balance each other. When we resolve the y components of this, from the figure we can get that the y components are E minus q sin theta and E plus q sin theta, and these two components, they are equal in magnitude but they are opposite in direction, so they just cancel each other. And when we resolve the x components of this electric field, then what we get? That is minus q cos theta E plus cos theta. These are the x components of, and these two components are equal magnitude but they directed along the same direction. These two components, they equal in magnitude but they directed along the same direction. So what will happen? They will add up. Therefore, the electric field produced, the net electric field produced by is equal to E minus q cos theta plus E plus q cos theta. So that is the magnitude of the electric field, the net electric field produced by the positive and negative charges in a dipole. The magnitude of the net electric field, the total electric field at the point P can be written as E is equal to 2E minus q cos theta, that is equal to 2 into 1 by 4 pi epsilon 0 q divided by r plus a whole square into a divided by square root of r plus a square, or r square a square. So this we can write 2e minus q into cos theta divided is equal to 2 into 1 by 4 pi epsilon 0 into q divided by r plus a whole square into a divided by here r square plus a square. Now we can multiply this term, 2 into q into a, that is equal to 2 into q into a divided by 4 pi epsilon 0 r square plus a square all raised to 3 by 2. Now from this equation, it is clear that the direction of the electric field produced here is opposite the direction of the dipole moment of the dipole. So we can write E, the electric field produced E is equal to 1 by 4 pi epsilon 0. 2 into q into a can be written as the dipole moment P. P is equal to 2qa divided by r square plus a square whole raised to 3 by 2. this case, if the value of r, or the distance between these two, between the dipole and the point, is very large, in a case r is equal to much greater than r, then what will happen? The term a will be negligible. Then what we get? Then E can be written as that is equal to 1 by 4 pi epsilon 0 into P divided by R. In such a case, special case where the value of R is much greater than A. And since the direction of the electric field produced is opposite of the direction of dipole moment, then a negative sign is added up here. So minus of 1 by 4 pi epsilon 0 into P divided by R square plus A square whole raised to 3 by 2. Next, a dipole in a uniform external electric field. Consider a dipole minus Q plus Q placed at a distance between them, and the direction of the dipole moment is in this direction. The perpendicular distance between these points, here the point B, A, B, C. Okay. Now, an electric field placed perpendicularly between the distance A, C, and this is the direction of the electric field produced, and there is a force on this, acting on these two charges, that means at the point A and the point B, and this is the direction of the force, that is QE is acting on the point, negative QE is acting on at the point A, and another force acting on the point B, that is QE. Okay, and these two forces are equal in magnitude, but they are opposite in direction. Therefore, the net force of the dipole is 0. However, these two forces are acting on two different points separated by a distance AB, and this, what is it? They are separated by a distance 2A. Okay, the distance between A and B is 2A. Hence, these two forces constitute a couple for the magnitude of the torque. Tau is produced there, and torque is equal to, and how this torque is produced? That is, the torque is produced either the charge, either positive or negative charge, into the distance separated them, the perpendicular distance between the anti-parallel forces, that is equal to the distance. So, either the charge can be written as Q into the distance, perpendicular distance between them is what? That is AC. That is equal to Q into, the AC can be written as 2A sin theta. It can be written as 2AQ into E sin theta. That means the electric field produced by the, so that is equal to 2AQ can be written as PE sin theta. If you write in this vector notation, the torque can be written as tau is equal to P into E. This is the magnitude of the torque produced by a dipole in a uniform external electric